I am Dr. S.Padmapriya speaking to you. I am guiding the students in their preparation for the UGC NET Economics exam. In my previous video, I have already covered the first lesson of microeconomics, which is the theory of consumer behavior. And I will be completing 5 lessons in the first course, which is the 5 lessons of microeconomics. Now I will be proceeding to the lesson number 2 of microeconomics, which is the theory of production and costs. Now, what is factor of production? It may be defined as that good or service which is required for production. There are basically 4 factors of production. Land, which includes all the gifts of nature. We have labor, which is all mental and physical work. We have capital, which is all man-made resources. And we have organization, which is bringing together land, labor and capital. Now, under labor, we need to understand a concept known as Malthusian theory of population, which is given by Thomas Robert Malthus in his essay on the principle of population, which is published in 1798. According to Malthusian theory, population increases in geometric progression, whereas food increases in arithmetic progression. Overpopulation can be corrected by preventive measures like late marriage and by positive checks like famines, floods, disease or pestilence. Now we have to understand the concept of scales of production. The scale of production refers to the amount of factors used in the quantities of products produced and the techniques of production adopted by a producer. Now we have 2 important concepts, which is internal economies of scale and external economies of scale. Internal economies are internal to a firm when its costs of production are reduced and the output increases. The benefits are available only to individual firms. In the case of external economies, they are available to the firm when the scale of production of the entire industry increases. Example, the ones caused by inventions and others. What are the types of business units? We have sole or individual proprietorship, we have partnership, we have joint stock company, we have cooperative societies, and we have public undertakings. Now, what is a production function? According to Stigler, the production function is the name given to the relationship between the rates of input of productive services and the rate of output of product. Here Q is the function of labor, management, land, capital and technology. So basically, production is the transformation of input into output. Now we come to the important concept of law of diminishing returns. According to Alfred Marshall, an increase in labor and capital applied in the cultivation of land causes in general a less than proportionate increase in the amount of produce raised unless it happens to coincide with an improvement in the arts of agriculture. In other words, the law states that as we use more and more units of a factor of production to work with one fixed factor, after a particular point we get less and less marginal output or marginal product from each additional unit of the variable factor used. Now, we have another concept called as law of variable proportions. According to the law of variable proportions, as the quantity of a variable input is increased by equal doses, keeping the quantities of other inputs constant, total product will increase, but after a point at a diminishing rate. First the marginal product, then the average product, and finally the total product will diminish. The law of diminishing returns is only the first phase of the law of variable proportions. Now let us try to understand the graph 2.1. We have taken unit of the variable factor along the x-axis and output along the y-axis. We can see the TP curve which goes up and then which comes down. We have the average product curve or AP curve also going up and then coming down. We have the marginal product curve which goes up and comes down. What is it? In the first stage of the graph above, we have between points O and point B, we have increasing returns. That is, average product reaches the maximum and equals the marginal product at point E. In stage 1, the total product also increases rapidly. Stage 1 is the stage of increasing returns. When more units of the variable factor, say labor, are applied on a fixed factor, say land, production increases more than proportionately, and this is known as stage of increasing returns. Point A, where the tangent touches the TP curve, is called inflection point, up to which the TP increases at an increasing rate and from where it starts increasing at a diminishing rate. Stage 2 starts when the average product is at its maximum to 0 point of the marginal product. In stage 2, the returns are diminishing. In stage 3, we see that it is a stage of negative marginal returns. So production cannot take place in stage 3. What is the law of returns to scale? The law of returns to scale describes the relationship between outputs and the scale of inputs in the long run when all the inputs are increased in the same proportion. In graph 2.2, we are able to see that when all the inputs are changed in the same proportion, like here in stage 1, it is the stage of increasing returns to scale. Stage 2 is the stage of constant returns to scale, and stage 3 is the stage of diminishing returns. Here marginal product is taken along the y-axis and scale of input is taken along the x-axis. So stage 1 is returns to scale increases because the increase in total output is more than proportionate to the increase in inputs. The rate returns to scale becomes constant in stage 2 as the increase in total product is in exact proportion to the increase in inputs, and in stage 3 we have the returns to scale diminish because the increase in output is less than proportionate to the increase in inputs. So we have another concept called as isoquant. Now in the theory of production, we have this concept of isoquant, which is similar to the indifference curve in the consumption analysis. So the isoquant in the production theory is like the indifference curve of the consumption theory. An isoquant is a set of all possible combinations of two inputs, labor and capital, which yield the same maximum possible level of output. The slope of the isoquant is known as the marginal rate of technical substitution. The marginal rate of technical substitution in production is similar to the marginal rate of substitution in consumption analysis, which is the rate at which the factor of production can be substituted for another at the margin without any change in the quantity of output. We have IQ as the isoquant in graph 2.3. Now we come to the concept of isocost. Isocost curves represent the different combinations of two inputs that a firm can buy for a given sum of money at the given price of each input. They are also known as outlay lines, price lines, input price lines, and so on and so forth. The slope of the isocost curve is equal to the ratio of the marginal product of labor to the marginal product of capital. So here we see the isocost curve GH. We have units of labor along the x-axis and units of capital on the y-axis. What is producer's equilibrium? This in graph 2.5 it is point M, where the isocost curve GH is tangential to the isoquant, which is IQ. So producer's equilibrium refers to the least cost combination of factors to produce the largest volume of output. In graph 2.5 we notice that the slope of the isocost line must be equal to the slope of the isoquant line for producer's equilibrium at point M. Now we come to the concept of production cost. It refers to the expenses incurred in the production of a commodity by a firm. There are different types of cost, like explicit costs which are entered in account books, and we have implicit costs which are the cost of the entrepreneur's own resources and services. Then we have opportunity cost, which is the alternative foregone or opportunity missed. We have total cost, which is nothing but total fixed cost plus total variable cost. So what are total fixed costs? Total fixed costs are those costs of production that do not change with output. We have to pay them even if we don't produce any output at all. They're known as overhead costs, like rent, interest on borrowed money, insurance charges, property tax, depreciation, maintenance charges, wages and salaries of permanent staff must be paid under any circumstance. And then we have total variable costs, which are costs which change according to output. They're known as direct costs. They rise when output increases. They include expenses on raw materials, power, water, taxes, hiring of labor, and advertising. Now let us go to the graph 2.6, which represents the total cost curves. We have TC, which is total cost curve, TVC, which is total variable cost curve, and TFC, which is the total fixed cost curve. The above graph 2.6 depicts three cost curves. The first one is the total cost curve, which is a continuous curve, which shows that with increasing output, total cost increase. The total cost curve cuts the vertical axis at a point above the origin and rises continuously from left to right. This is because even when no output is produced, the firm has to incur total fixed costs. The total fixed cost curve is shown as parallel to the output axis. The total variable cost has an inverted S shape and starts from the origin O because when output is 0, TVC is 0. Now we have short and average costs. They are average fixed cost, average variable cost, and average total cost. Average fixed cost is equal to total fixed cost divided by the quantity of output. Short-run average variable cost is equal to total variable cost by quantity of output. And short-run average cost is total cost by quantity. Now we come to the graph 2.7, which shows that various short-run cost curves. We have SMC, SATC, SAVC, SAFC. SMC is short-run marginal cost curve, SATC is short-run average total cost curve, SAVC is short-run average variable cost curve, and SAFC is short-run average fixed cost curve. Output is taken along the x-axis and cost is taken along the y-axis. The U-shape of the short-run average cost curve can be explained in terms of the law of variable proportions, according to which when the quantity of one variable factor is changed while keeping the quantities of other factors fixed, the total output increases, but after a period of time it starts to decline. What is the relationship between the various cost curves in the short run? The average fixed cost curve is asymptotic to both the axes. It declines continuously. It means the AFC is a rectangular hyperbola. The short run average variable cost curve first declines, then reaches a minimum at point A and then rises thereafter. The short run marginal cost curve equals the short run average variable cost curve. Short run marginal cost curve equals the short run average variable cost. When average cost falls, marginal cost is less than average cost. When average cost is minimum, AC is equal to MC. When average cost rises, marginal cost is greater than average cost. Long run cost curves. Now we come to the concept of long run average cost curves in graph number 2.8. We have LMC, which is long run average cost, and we have LMC, which is long run marginal cost. In the graph 2.8 above, the long run average cost curve is tangent to the lowest point of the curve, which is E. It is tangent to all the short run average cost curves, but only at its minimum point. So every short run average cost curve represents the individual plan's cost curve. The long run marginal cost curve is flatter than the short run marginal cost curve. Thus, we come to the end of the theory of production and cost. Thank you.